After we know how to do the Laplace transform for all kinds of functions, now we should know the inverse Laplace transform as well. Just like you know how to go forward, you need to know how to go backward as well. So if you have Fs as a Laplace transform of Ft, so to go back to Ft, you need to take inverse Laplace to Fs. And this is going to be the symbol that we use for inverse Laplace transform. Very simple technique. Find the way back. Okay? Let's see example. Number 1. Inverse Laplace of 3 over s squared plus 4. What is that? So, when you see s squared plus 4, it comes from s squared plus 2 squared. When you see this one, I'll probably think about sine 2t. But to have sine 2t, we need 2 up here. But the original problem, we don't have 2 up here. So we write up 2 here. You need to divide out with 2. So it's just like multiply with 1. 3/2 is just constant. So it's equal to 3/2 times inverse Laplace of 2 over s squared plus 2 squared. So it's equal to what? This term, sine 2t times 3/2. Here we go. Not bad, right? See number 2. Inverse Laplace of 2 divided by s plus 5 power 4. How are we going to do it? When you see something power 4, it should come back from this one, right? Laplace transform of t power n is n fact over s to the n plus 1. So n plus 1 here is 4. I should have 3 factorial here. So I just write up 3 factorial and I divide it with 3 factorial, divided with itself. So nothing changed with this function. 3 factorial is what? 6. 2 over 6, 1/2. I factor 1/2 out. And inside here is what? 3 factorial over something power 4. So in here, we should have something like t power 3. And then you see, it's not just s, it's s plus 5. It should come back from s minus 5. That means you do shifting with negative 5. So recall this, if you have e to the at ft times is equal to f of s minus a. To have this, you need to get e to the negative 5t, right? And then times Laplace inverse of 3 factorial divided by s to the 4th, which is what? T cubed. And then you times with this for times with shifting e to the negative 5t. Okay, let's see number 3. Inverse Laplace of s plus 1 divided by s squared plus 4. When I say this term, I probably think of sine cosine 2t, but how are we going to do that? So we need to split this out to 2 terms. S over s squared plus 4 be the first term, plus 1 over s squared plus 4 be the second term. So the first term is quite complete. So this is a form of cosine 2t already. But this one, when you see 2 squared, you need 2 up here. So you divide by 2 here. And you factor 1/2 out. And the rest of the term here is exactly comes from sine 2t, right? So you're going to have cosine 2t plus 1/2 sine 2t. After you do Laplace transform, you can do it. You can check your solution. If you transform this back, you should get this one. And when you do the inverse Laplace transform with this one, you should get this one. Number 4. For number 4, inverse Laplace of s plus 1 divided by s squared minus 4. Let's say if you don't use, you can split this out to be s over s squared minus 2 squared plus 1 over this. And then you're gonna use the notation of what sine hyperbolic and cosine hyperbolic, or you can use this method. Let's see, I use the difference of the square here, so I factor s squared minus 4 to be s minus 2 times s plus 2, and then I use partial fraction. This whole term we can split it out to be a over s minus 2 plus b over s plus 2, and after the calculation I found that a equal to 3/4 and b equal to 1/4. So you plug in and you get this term. Okay, plug in a, plug in b in there. After you plug in, and then because Laplace transform, you have linearity, so the inverse Laplace transform also have linearity too. I'm going to factor 3/4 and then distribute the Laplace inverse to each term here. This is what we got. See that? So we have 3/4 times inverse Laplace of 1 over s minus 2 plus 1/4 times inverse Laplace of 1 over s plus 2. What is that? This one, it comes from what? E to the 2t. And this one comes from e to the negative 2t because s minus 2. Here we go. This is the solution. What's next? Okay, see next example. For each example here, I would recommend you guys close the detail and try to work on each problem by yourself so you can practice, make sure you understand. You can do find Laplace transform quickly, and you can find inverse Laplace quickly too. Next one. When I say s times s minus 1, I will think of partial fraction. So I take 4 out and then I use the partial fraction, and I found that this term can be split out to be 1 over s minus 1 and 1 minus 1 over s, and then I just distribute Laplace inverse to each term, and this term obviously is e to the 1t, and this one comes from 1, and this is what we got. Here we go, one more example, one more problem for you to try on. Laplace inverse of 2s squared minus 3s plus 2, all divided by s plus 2 times s squared plus 4. When I see this, I will think of partial fraction. So we have one factor is linear and one factor is a reducible quadratic. So when you set up the linear factor, is what? Constant over the linear factor plus the linear over the quadratic, the irreducible quadratic. So please check this. I'm not sure, just in case I'm wrong. So I found a equal to 2, b equal to 0, and c equal to minus 3. So once you plug in, you see this should be simple. It's 2 and 1 over s minus 2. It's e to the negative 2t, right? And this one, b equal to 0, so you have only minus 3 divided by s squared plus 4. So you just simplify the form and you should get 3 over 2 times sine 2t. Shouldn't be hard. I think I have last example for you. This one, I would like you to find inverse Laplace of what? S over s squared minus 6s plus 13. So from here, when I see 13 and I see negative 6 here, I don't think I can factor this. So I'm thinking of making it a completed square. So s squared minus 6s plus 9, I can combine it to be s minus 3 squared, and then minus 9 plus 13 is 4. It's in the form of what? Here it's like shifting 3 units. It should be e to the 3t come out. And here plus 2 squared. So on the top we have s. So we should have, in terms of cosine something, so we should have s minus 3 as well. So I just minus 3 plus 3 here, and then I split it out to be 2 terms. So this term I have s minus 3 over s minus 3 squared plus 4. It should comes from shifting 3 units e to the 3t of what? Cosine 2t. How about this side? This side is what? It's 3 divided by, because it comes from the second term, 3 divided by s minus 3 squared plus 2 squared. But as you see, this one I see 2 here. The top part here, to make it become sine 2t, it should have 2 here. So I just plug 2 here and divide it by 2 too. And I have the new constant come out, 3/2. And you see, we have to shift s 3 units. So I need to multiply e to the 3t and then sine 2t. All right. Now suppose we know how to do Laplace transform and how to do inverse Laplace transform. Next, we're going to use this idea to find the solution of the initial value problems. Let's see on the next video.